So what is Python? If we define Python, then you can say that Python is an interpreted, object-oriented, high-level programming language. Now, these three terms independently are a subject in itself, but we would like to go in a little bit detail and try to understand what these three terms mean before starting learning Python. So there are two kinds of programming language we would like to compare. The one is interpreted language, which uses an interpreter, and the one is the compiled language, like C++ and Java. If you go and try to understand what is, if you go online and try to look for what is interpreted language as compiled language, you'll get tons of material to study on. But let's try to have a look at it quickly. So interpreted language. What happens in an interpreted language is when you run a Python file or when you run a execute a code in Python, it starts running it starts executing the code line by line. It doesn't compile and makes a executable of its own. So as the source code, first the source code is converted into something called a bytecode, and this bytecode is not exactly like a machine code as in compiled languages. So this bytecode is something which is understood by a Python virtual machine. Again, it's not a big virtual machine like a whole operating system, but a smaller version of the virtual machine, which basically understands this bytecode and then it executes on the CPU directly. So let's get it down shortly. So in a Python language, you take the source code, and then the source code is basically converted into something called a bytecode, which is understandable by a virtual machine, which is called the interpreter. And this interpreter takes in the bytecode and then it gives us the required output by executing it, what we get as an output of any command what we write. We'll go through and see how this bytecode looks like by just maybe making a function and trying to see how it basically how this bytecode look like as compared to a compiled or a machine code. And second thing was as we was talking about the compiled languages. The compiled languages, first the source code is converted into something called a machine code by a compiler. And during this compilation, the compiler basically checks for every possible error which it can see. And then during the compilation itself, it can give you a throw error. Like when you're executing a C++ or a Java program, you would have faced sometimes compilation error when you try to execute the program. But in Python, you don't get something like a compilation error. During the time when the bytecode is being prepared from the source code, yeah, it does check the syntax where the syntax of the code is right, and it throws a syntax error at that same time. And after the compile is passed through the compiler, it is basically converted to machine code, which is directly understood by the processor or the CPU on our machine, and then it's executed, and then we get the output. That's how the basic difference is. Now let's go and have a look over how the a C++ machine code looks as compared to a Python bytecode. So here I have made a very simple program in C++, like a function which is called age is valid. It takes in an integer called age, and then it just gives, if the age is greater than 5, it returns us a true value, and if the age is less than 5, it returns a false value. If I just run this one in the debug mode and just click on execute, and then try to do click a right click, I put a breakpoint at that function call, and then I go to the disassembly and see, yeah, see, this is how the actual machine code looks like when it is a C++ program. So at the end, it's like CPU instruction, push, move, sub, push. And when we go and see the same thing in Python environment, like suppose here I make a something similar function and I use a library called this in order to just check this one, how it looks like. Let us execute it on a terminal so that we have a clear look of it. So I run this one. So I say Python main.py, and then I get the bytecode. This is how the bytecode looks out in Python when we execute the file called this one. It's load fast, load const, compare, pop up. We don't want to go into detail and look over each of this instruction. Maybe it's outside the scope. So we just learned what is the difference between an interpreted and compiled language. It's a little bit important to understand that because Python is an interpreted language. The next thing is OOP, that is object-oriented programming. And Python is an object-oriented language. If you're new to programming, this term is pretty confusing, but don't worry. When we get into the videos where we'll try to create our own classes and objects, we'll learn these OOP concepts pretty well.
As of now, just take it that OP is nothing but kind of a programming style in which we define everything in terms of objects and classes. And we'll go very much detail into these objects and classes later. If you want to learn more about what is actually object-oriented programming, it's in a subject in itself, and then you can look online and you can find tons of material for just object-oriented programming and how we define it. Just to get you into Python. In Python, most of the things what we'll do is object-oriented, and we'll create objects of the classes. For an example, list. When we create a list by using the command list and bracket close and open, we are creating an object of the class list which exists in Python. And same happens when we start to create a dictionary or when we start to create any other data types in Python. And we'll have a look over it as it comes into play. So we just have a look over what is the difference between interpreted language, compiled language, and what is OOP. The next thing important in Python is dynamic typing. If you have ever used other programming languages like Java or C++, you would have noticed that you define the type of the variable before compilation. When you start writing the code, you basically tell that this variable is of type integer or float. But in Python, this interpretation of the type of the data is done at runtime. That's why it is called dynamic typing. Let's go and have a look at some examples and we'll understand this in more details.
So we just studied that Python is an interpreted object-oriented and dynamic typed programming language, right? We already saw this in a little bit detail, but we want to basically see what is this base and how it compared to different languages. If you have used other languages like C, C++, then you know that for using a variable, we need to define the type of the variable before we start using it. So if I want to have an integer, then I say something like int x. If I want to have a float, then I say float y, and then I assign an integer value on x and the float value on y. But in Python, if I need an integer, I will just say x is equal to 10. And if I need a float, I just say y is equal to 10.5. So nice. I don't have to basically declare the type because the type is decided at runtime. Let's try to see this in code directly. So I go there and just try to open a command prompt just to get ourselves in practice of using the virtual environment, which we just learned in the first video. If you haven't seen that, just go to my first video and have a look over it. And I would add the link of this first video right at here in the corner. So I want to go and activate the virtual environment, and here, so I take the location and then I paste in here, and there's a venv scripts activate. Cool. Now we have the virtual environment. I want to go here, just let's delete this one and then say Python. Cool. Now I want to declare a variable as an integer or assign an integer variable to the variable. I just say that 10. Let's check what is the type of x. Print type x. It's an int. And if I say something like y equal to 10.1.7 and I want to know what is the type of this variable, then I say type and I say y, and that's a float. And if I have a string, maybe name equal to Henrik, and then if I say print type of name, it's a string. Now if I say something like a list, L is equal to list, just see here what I'm trying to do. List is a class and I'm trying to create an object of the class list, which is L, just to illustrate this object-oriented programming in Python. Now if I want to see the what is the type of L, then I just say print type of L. Sorry, I probably missed something. Print type of L. Yeah, so it's a list. That's super nice. Now let's exit. Let's try to basically summarize what are the things in Python, what we have learned till now. So we said, what is Python? We learned that Python is an interpreted object-oriented high-level programming language. It's dynamic typing. It's very useful for scripting. It has simple syntax, just like English language. How Python compared to other languages? Fast for development, for sure, because it's very quick to write code in Python. It's less complex. There are so many good libraries. If you want to do some machine learning, there are scikit-learn and so many other things which you can use in Python. And if you want to do some Excel manipulations, you can use the pandas. Yeah. If you want to do some mathematical thing, then you can use the NumPy. It's slow. Yeah, it's slow. It's not as real time as C++. It's platform independent, but Visual Basic, yeah, it's not platform independent. Yeah, cool. So next one, we'll see our first program, which is Hello World. That's how every programming layer course starts with. And we'll also see the basic data types of Python. So see you guys next time.